Mathematical hypothesis has 5 steps. The first step is finding the null and alternative hypothesis. The second step is defining the mathematical hypothesis, if it's less than, more than, or not equal. The third step is defining the type of test with the diagram. The fourth step is to calculate the statistic stat and the table. And the final step is the conclusion, defining if the hypothesis null is rejected or not.
To know the type of test, first we need to know if the number of sample is bigger than 30. If it is, we do a C-test. If it's not, we check if the standard deviation is from the population. If it is, it's a C-test too. And if it's not, we do a T-test. If the problem is sample versus population, we do a paired T-test.
The formulas to get the step 4 of calculating are different for each type of test. For C-test, we get the stat by doing x minus the average, divided by the standard deviation, which is divided by the square root of the sample. For the table, we just subtract the confidence from 1. If the test is bilateral, we do the same thing, but we also divide that in 2. For the T-test, we do the same thing as we did for the C-test. When it's a C-test, we need to look for the number in the table from inside out. When the test is a T-test, you need to subtract n minus 1, and also subtract the confidence level from 1.
How to know if the test is unilateral or bilateral. Unilateral wants to prove that one is better than the other, and bilateral wants to see if there's any change at all. It doesn't matter if it's better or not.
Let's suppose I started a new teaching method to see if it actually improves my students' grades. I teach a whole class of 35 students using that method. If at the end of the semester they score an average of 87 versus a historic average grade of 85 with standard deviation of 5, is that enough to satisfy my hypothesis with a 95% confidence? Our first step is to claim our hypothesis. By reading the problem, you know that you need to find the difference between testing the old test versus the new test. Our null hypothesis, H0, is that the new teaching method doesn't improve your grades, and the alternative hypothesis, H1, is that the new teaching method does improve your grades. Then, the second step is a mathematical hypothesis, where you apply your previous hypothesis in numbers. So we have that A is the old method and B is the new method. In our null hypothesis, you put that B is greater than A, and in the alternative hypothesis, A is equal to B. Then you need to identify the type of test, like we previously explained. In this case, our problem is a C-test unilateral. Our fourth step is to do our calculations. You measure your C-stat with the formula we previously explained, and our answer is 2.36. Then you do the C-tables and calculate it with the formula, so you have 1 minus 0.95, which is the confidence that is given to you in the problem, and then you search that in your C-tables, and you have your answer. Our fifth step is to compare our answers in the fourth step, and we concluded that the C-stat is greater than the C-tables. Therefore, our null hypothesis is rejected.
In a random sample of 27 students of 5th semester of Prepatec, the average score obtained from the domain exam was 1,132 points with a standard deviation of 44. In previous years, the average was 1,120 points. A math teacher claims that performance has improved due to his extra tutoring sessions. Test the claim using a significance level of 10%. First, we start the problem by stating our hypothesis. The null hypothesis is that tutoring didn't improve grades, and the alternative is that tutoring did improve grades. Then we do the mathematical hypothesis. So we have that A are grades with tutorings and B is grades without tutorings. The null will be that A equals B, and the alternative is that A is greater than B. The type of test is a T-test, and it's unilateral. Next, we do the calculations putting our numbers into the formula. Then we look for the significance number inside the C-table. We can see that the number in the stat is larger than the one from the table. Therefore, HO is rejected.
The masses of rabbits after a long period of eating only grass is compared to the masses of the same rabbits after a period of eating only rabbits' pet food. It may be assumed that their masses are normally distributed. The makers of rabbits claim that rabbits will get heavier if they eat their food instead of grass. Test this claim at 10% significance level.
From the table that they give us, we first need to get D. D is the average of the differences. After we get D, we can start the problem by stating our hypothesis. The null hypothesis is that rabbits' weight after rabbits will not increase, and the alternative is that rabbits' weight after rabbits will increase. Then we do the mathematical hypothesis. So we have that A is rabbit grass and B is rabbits. The null will be that A equals B, and the alternative is that B is greater than A. The type of test is a paired T-test, and it's unilateral. Next, we do the calculations putting D as the denominator and dividing. Then we look for the number in the table. And we can see that the number in the table is larger than the one from the stat. Therefore, HO is accepted. You are a phone manufacturer and want to test a cheaper battery for your phone. The old battery has a lifespan of 3 days. The new battery has a lifespan of 2.9 days, with a standard deviation of 0.5. You have a sample of 40 batteries. You claim that the new cheaper battery lasts the same as the old battery. Test this claim with a 95% confidence. First, we start the problem by stating our hypothesis. The null hypothesis is that the new battery lasts the same as the old one, and the alternative is that the new battery does not last the same as the old one. Then we do the mathematical hypothesis. So we have that A is new battery and B is old battery. The null will be that A equals B, and the alternative is that A is not equal to B. The type of test is a C test, and it's bilateral. Next, we do the calculations putting our numbers into the formula. Then we subtract 1 from the confidence level, and since it's bilateral, we have to divide it by 2. We can see that the number in the table is larger than the one from the stat. Therefore, HO is accepted.